Good morning.
Good morning.
Guys, my name is Christina Latimer. I'm one of the project coordinators for the Environmental Education Initiative, and we are so excited to have you here today. I think this is the biggest turnout we've had at one of these things in a really long time, and we are incredibly excited about it because these students behind me have done some amazing things this summer. We do have one student out. She was ill. So these guys are taking over her slides for her, and she wishes she could be here to share this with you as well. On that note, I'm handing it off to them because they're the stars of this show. Thank you.
Good morning, City Council officials, friends, families, and everyone else in the audience. We are the EEI interns of 2024, and we thank you for your appearance at this presentation today. To give you guys a rundown of what's gonna be presented today, we will introduce ourselves personally. We'll then go through some of EEI's programs, including this internship that we are all in today. We'll talk about some of the field trips and the professors that we met at UNT. We will then talk about the research pertaining to our leaf packs and EEI's research pertaining to water education. We will give our recommendations for next year's research interns and also give our personal takeaways and experiences. For the introductions, I'll get started. My name is Patrick Adao Perez. I graduated from Bishop Dunn Catholic School, and I will be going to the University of Austin at Texas to major in business with a focus in finance and a minor in African and African diaspora studies. One fun fact about me is that I play alto saxophone competitively in TPSMEA and ATSSB for both jazz band and concert band.
Good morning, everyone. Unfortunately, Serenity could not make it to the presentation today, so I'll be taking over a few of her parts, including her intro. So, Serenity Vanegas is a rising senior at the School of Science and Engineering at Townview. In the future, she wants to major in biomedical engineering, and a fun fact about her is that she loves to bake. Now for my introduction. My name is Alyssa Robert, and I'm a rising senior at Irma Rangel Young Women's Leadership School. I want to go into medicine, and a fun fact about me is that I've been to Pakistan 4 times.
Hey everyone, my name is Braden Brown. I am a graduate of Wilma Hutchins High School. I plan to attend Austin College and major in civil engineering. And a fun fact about me is I'm a magician with the cards.
Hi everyone, my name is Aaron Filliman and I'm an incoming college freshman at Babson College. One fun fact about me is that I was born in Ethiopia.
Hi, my name is Jose Juan Granados. I'm currently attending Trinidad Garza Early College High School as a rising senior. After high school, I hope to major in biomedical engineering. A fun fact about me is that I love running.
Hi everyone, my name is Raina Lee and I am a rising senior at the Hockaday School. In college, I plan on studying interdisciplinary studies such as engineering and data science, and one fun fact about me is that I have played tennis since I was 5 years old.
Hi everyone, my name is Carlos Lee. I'm a rising senior at the School for the Science and Engineering with an interest in physics, and I'm allergic to cats.
My name is Ainsley Johnson. I'm a graduate of the School of Science and Engineering, and I'll be attending Smith College in the fall for environmental science. A fun fact about me is I play 4 instruments.
Hello, my name is Edva Trejo. I am a rising senior at Ryan Evans High School, and I'm in the P-TECH program. I'm planning on studying nuclear medicine technology, and a fun fact about myself is I'm a hip-hop dancer competitively. EEI program. To start us off, we're going to show you a little bit about what EEI does to the Dallas community. Elementary schools. The biggest EEI program is teaching elementary school students. The elementary lessons are text-aligned and available to all elementary schools in Dallas. EEI teachers are certified teachers who teach hands-on lessons when they are requested. They are also provided on hands-on lessons to the kids. When the EEI team teaches students, they want to ensure that the students remember the lessons in accordance of water conservation. Each student is given the opportunity to sign a commitment to save water by turning it off when they brush their teeth. They also receive a water conservation item that they take home to continue their lessons and teach their families. Kinder through second grade get the Water Heroes coloring book, and third through fifth grade receive a toothbrush holder with a timer. These are the items the students receive. Middle schools. For middle school students, the teaching EEI does is more discussion-based. EEI physical models to provide talking points and discuss water conservation to water quality with the students. Middle school students are given the opportunity to commit to saving water, just as they are for elementary school students. However, these cards help the students describe how they're going to help conserve water and keep it clean. For example, the students above said that they will take shorter showers and not put trash in the toilet. Middle school students are also given water conservation items. They get a shower timer to take home and practice using less water. These are the items the students receive.
EI will also attend a variety of different community events, like outreach events or back-to-school events, such as Homeschool Day at the Zoo or EarthX. At these back-to-school events, the EI mentors will give out classroom materials like bags or pencils, as well as educate the community on what EI actually does. At the outreach events, such as Homeschool Day at the Zoo, as you can see in the photo there, the EI mentors will go and teach a lesson like the ones they teach to the middle schoolers or elementary schoolers. In addition to community events, EI will also provide professional development to teachers in Dallas. At these professional developments, the teachers will train this class on lessons on water conservation, as well as having them take part in the lessons themselves. They are also provided with materials and conservation items to help them run the lessons more smoothly. High schoolers are also given many different opportunities by the EEI program, starting with the EEI Research Summit. The EEI Research Summit is a summit where students are tasked with coming up with a research question revolving around water conservation. They will then present this research that they find to UNT professors and other Dallas City officials at the end of the school year. If their question is accepted, UNT will provide all the equipment they need to run their experiment and do individual research. At the end of the school year, they present their poster at the end of the summit at their individual schools. I was able to participate in the Research Summit, and what I learned was a lot more about how to work together in teams with people, especially taking on individual research that one might think is way out of your depth. And then I also learned a lot more of just how to improve my presenting skills. After the summit, over summers, the EEI program also provides opportunities for students to enter a video contest. During this video contest, students will create a short form video essay that will educate the public on different water conservation programs, like EEI. So after that, what we have now, and what brought you all here today, is the EEI internship. So, on that note, this summer internship has been full of awesomeness, and please allow us to tell you more about the fun opportunities and experiences we had over this summer, starting with our research articles and presentations explained by Brayden.
Thank you, Carlos. The first assignment we did together was our research articles and presentations. We broke up into pairs and were each assigned a topic with an article. The deep dive we took into these articles helped build our research skills and gave us foundation into this program and the research we would conduct. We then gave presentations to our group that went over the experiments and the results we found. And we would end the presentations with our biggest takeaways on the experiments conducted. These are the topics that we researched. Each of these were picked due to their relevance to EEI and water conservation. EEI, of course, teaches the youth about water conservation. The article on attitudes tells us about people's mindsets on their water usage. The perception of water reuse goes into what the public thinks about water reuse. And Fishbein's study of behaviors tells us how behavior could influence water usage habits. The last article is GIS, and my friends Raina and Aaron can tell you more on that.
Thank you, Brayden. GIS stands for Geographic Information Systems, and it is the art of storing, manipulating, analyzing, and displaying spatial data as maps, 3D charts, and more. Some examples of GIS that you may have seen on the news include weather forecasts and land use projects. These maps are created by software engines such as ArcGIS Pro and Google Earth Engine. As interns, we had the wonderful opportunity to learn how to use ArcGIS to create our own maps with variables such as population density, ecoregions, precipitation levels, household income, and more.
So now that we have a basic understanding of what GIS is, we'll show some examples of maps we created using a software called ArcGIS. Up on the screen is the first map we created, which shows all of the elementary schools impacted by Dallas EEI. And impacted simply means schools that have been visited by the EEI team. The colored areas are the Dallas City Council districts. The blue stars are the elementary schools visited by the EEI team, and the black dots are the schools not visited by Dallas EEI. And this is our next map, which is on the screen, and it has the same setup as the previous map, but it includes all school categories, including elementary, middle school, and high schools. Both of these maps show a solid representation of which areas have been reached by Dallas EEI and which areas still need to be reached. Now, a few of our other interns are going to speak about the UNT professors we met during our internship.
Throughout this internship, we had the opportunity to speak with and talk to 3 different UNT professors who told us a bit about themselves and taught us about their research, starting with the director of the EI program, Dr. Rudy Thompson.
As Carlos mentioned, Dr. Thompson was the first professor we met at UNT, and she taught us the importance of networking in a collegiate environment. She also informed us how every encounter with a person is an opportunity to obtain knowledge, to explore a career path, or even to apply for an internship. After we introduced ourselves and our majors, she then referred us to a person in our field. For example, I told her I was interested in environmental science and environmental law, and she referred me to a person in that field, an environmental lawyer. Ever since that meeting, I've been able to appreciate interaction and communication with both my professors and peers alike.
The next professor that we visited was Dr. Mager, an environmental toxicologist. Environmental toxicology is simply looking at different chemicals and analyzing their impacts on the surrounding environment. One of the projects he showed us were the fish swim tunnel respirometers, and that's just fancy for a treadmill for fish. So Dr. Mager will then use that treadmill to analyze the fish's health by determining its swimming abilities. He then can test the effects of different chemicals on the fish. Another project he showed us were his self-contained prawn water tanks. And that just means a dripping water tank that recycles water by trickling it through different tanks of prawns that can help clean the water. The 2 takeaways I found the most important after reflecting on this experiment was 1, just how resilient the environment can be. Now, after constant exposure to different man-made chemicals, the environment can still thrive. The second thing I found the most important was just learning how to know what to research and how to come up with good research questions, and how even then it's not only about coming up with good research questions, but also just about noticing interesting patterns. So thank you to Dr. Mager for teaching me.
The third professor that we talked with was Dr. Kennedy. Dr. Kennedy is a UNT Regents professor in biology who specializes in invertebrates and their relationship to water in an ecosystem. In his lecture, he taught us about aquatic insects and some of their stages. For example, at the adult stage, they usually all leave the water to reproduce and become important in a functioning ecosystem. In an ecosystem, the aquatic and terrestrial ecosystems are usually connected. Healthy streams and healthy terrestrial systems are dependent on one another. When a leaf falls in a stream of water, it is broken down into soluble nutrients by bacteria and fungi. Now, this was very interesting to hear because I wasn't aware of how important terrestrial components are for aquatic life, such as invertebrates. Later on, Ansley will talk more about how we use this information to explore the relationship between the presence of certain invertebrates and the quality of water. But before we get into that, Braden will talk about some of the field trips that we went on.
Thank you, Alyssa. A big part of our internship were the many field trips we took. Each one offered different knowledge and insight into environmental education, and they were all very enjoyable. Okay, so the first field trip we will discuss is our trip to Central Wastewater Treatment Plant. Central uses chemical, biological, and mechanical methods to treat the water. We were given a tour of Central, and we learned the different stages that water goes through to be treated before it's released back into local waterways. My favorite part was definitely the trickle filters, which were giant machinery that took water from the clarifier pools and then trickled them down deep layers of rocks. I thought it was very cool how they use nature as inspiration for this technology, whereas when in nature, When you have running water, like from a waterfall, and it goes through rocks, it acts as a natural filter. Central is full of these interesting processes to treat the water. However, these processes go mainly unknown to the public, and there was no existing video to teach this. So we created our own, titled Central Wastewater Treatment, Dallas, Texas. And it goes over the steps on how wastewater is treated. You can find it on YouTube on the Dallas EEI page. On the same day as this field trip, we had the opportunity to visit Powell's laboratory, which Raina can enlighten you more on.
Thanks, Braden. Like he said, we had the wonderful opportunity to tour the Powell's Analytical Laboratory on the same day as our field trip to Central. At Powell's, analysts test the water quality of samples from all around Dallas, not just from Central. We gained exposure to the various experiments and procedures that are used to test these samples, and it reminded many of us of our high school chemistry classes. We also had the opportunity to hear from and learn from Dr. Whitcomb, who is the Superintendent of Environmental Quality and Supervisor at the Powell's Lab. She explained to us the details of working as an analyst in the lab, including the education and background needed for this career and what to expect when going into this field. Next, Alyssa will talk about our trip to Bachman Water Treatment Plant, where we learned where our drinking water comes from.
Thank you, Raina. After Central, we visited the Bachman Water Treatment Plant, where Chase and his team gave us a tour of the facility and taught us about the steps involved in the cleaning process. We also got a look into the various careers that are a part of this field. I learned that the water goes through 3 main processes: treatment, purification, and distribution. The treatment process starts off by the addition of chemicals to disinfect the water and moves into the removal of waste and filtration. After the water is treated, it goes into the purification stage. This is where the water is purified with chemicals such as chlorine, ammonia, and fluoride. Lastly, after purification, the water is distributed to customers through a system of pipes. After our visit to Bachman, we created a video sharing our findings, just as we did for Central. Out of everything that I got to see, my favorite part was definitely the distribution process. It was so interesting to see all the machinery that gets clean water to my house, and then same process behind the simple act of taking a shower. Next, you'll be hearing from Jose, who will talk about our visit to the White Rock Pump Station.
Thank you, Alyssa. After Bachman, we went to White Rock Pump Station, where the Dallas Water Quality Division held a presentation. We learned how the department monitors and tests water quality to stay in compliance with federal, state, and local environmental regulations for the public safety. From field services out in the city conducting meter investigations, to source water quality sampling lakes and tributaries across the state, to project coordinators, every team in the division works to keep the public safe. My favorite part of the trip was when we were able to look at the equipment they use, including sensors, vials, machines, and much more. Later on, we went to White Rock Lake Park to conduct water sampling with similar equipment the source water quality team would use. Although we had to be careful with the very, very expensive equipment. Near the end of the trip, a project coordinator showed us around the station while talking with us about career opportunities in Dallas water utilities. Next, you will hear from Patrick about our field trip at John Bunker Sands.
Thank you, Jose. Next, we will continue our journey to John Bunker Sands Wetland Center. The JBS Wetland Center is located just outside of southeast Dallas in Seagoville, Texas. One of the most important ecological functions it provides is its ability to purify water. Some of the wastewater that comes from the Trinity River will end up at the Wetland Center, where it will be phytoremediated, or living plants cleaning up soil, air, and water contaminated with hazardous materials. In the Wetland Center, there are about 2,000 acres of wetlands distributed over 28 cells. As the water flows from north to south very slowly, the solids will sink to the bottom in a process known as sedimentation. At the same time, the aquatic plants will also phytoremediate the water to reduce and remove harmful levels of nitrogen and phosphate. By the time it gets to the end of the Wetland Center, it will be pumped 43 miles up to Lake Lavon. This entire process takes about 2 weeks from the beginning to the end of the Wetland Center. In the end, about 91 million gallons of water are processed per day. On our visit, we wanted to see how clean the water was after all the natural processes were conducted. So we collected some water samples and also catch some aquatic animals. Once we got our water samples, we placed them in small vials, mixed in some dissolvable chemicals, and compared them to the color charts per the directions of our sampling kit. When we collected the water samples, we tested for pH, phosphorus levels, oxygen levels, and nitrogen levels. We also recorded some of the water temperatures, the odor, the turbidity, and the weather for that day. Depending on the water sample results, we then gave it a rating. We also captured some macroinvertebrates to determine the water quality as well. We used an animal sensitivity chart to determine which animals were most sensitive to water pollution. If there were a lot of animals in our sample that were sensitive to water pollution, then that means our water quality was good. So, for example, we found freshwater shrimp and fish fry in our water sample, which are highly sensitive animals to water pollution. That means our water quality was good. After plotting all our data from both water tests and the pollution sensitivity test, we found that the water was considered high quality or even good quality. Now I'll pass it on to Aaron, who will talk about our experience at Lake Tawakoni.
So the first field trip we went on was to Lake Tawakoni State Park. Lake Tawakoni is a reservoir located about an hour east of downtown Dallas, and it is one of the 6 reservoirs that provides water to Dallas. We had 2 total trips to Tawakoni. In our first trip, we placed 2 leaf packs, and in our second trip, we returned to retrieve them. But Ainsley will go into more detail on our leaf packs. Additionally, we went on a hike at the state park and collected trash around the area. After our trip to the state park, we went down the road and had a visit with the Sabine River Authority office for Lake Tawakoni. The Sabine River Authority manages the Sabine River watershed and its tributaries around East Texas and Louisiana, which runs through 21 counties. The specific Sabine River Authority office we went to manages the overall operation of the Lake Tawakoni Reservoir. We met with some of the people who work in that office, and they gave us a short presentation and showed us a video to give us an overview of what they do and provided some information on Lake Tawakoni, as well as the Sabine River watershed and some of the different plants and animals found in them. After this, we took a short drive to the Iron Bridge Dam located on Lake Tawakoni and even went under the spillway for the dam to look at some of the machinery. My personal favorite part was being able to get a close-up look at one of the source lakes for Dallas and being able to go under the spillway. That is the spillway right there. Now I'll pass it off to Ainsley, who will talk about our experience at Lila.
The Louisville Lake Environmental Learning Area, or LELA, strives to preserve and restore native Texas ecosystems and biodiversity while providing opportunities for environmental education, research, and recreation, as stated by the mission statement on their official website. They offer recreational experiences such as birdwalks and kayak tours, in addition to educational opportunities for all ages, from summer camps to graduate research. On our trip to Lila, we spoke with Conservation Manager and Associate Director Richard Freiheit, who discussed environmental and conservation career opportunities. We collected and analyzed natural leaf packs, on which I will speak more in our next section. My favorite part of Lila was getting hands-on experience with live organisms. During this internship, we explored 2 research topics. The first is Dallas water quality. Through field trips to water treatment plants and local aquatic ecosystems, discussions and presentations from professors and professionals in the field of water quality, and the use of leaf packs, we learned how Dallas achieves and maintains its excellent water quality. The second is water conservation through education. To what extent does conservation education impact water consumption? We performed statistical analysis of data collected by the EEI team and mapped our findings using GIS software to answer this question and more. The term leaf pack refers to the buildup of leaves in streams. Leaf packs provide nutrients and a habitat for aquatic species. By collecting leaves from the immediate area, we can mimic leaf packs and gain valuable insight into the water quality of the ecosystem. We placed leaf packs at Lake Tawakoni and Lila. Following the recommendation of last year's interns, we placed the Lila leaf pack earlier than previous years. The pack was placed by the EEI team on May 9th and was supposed to remain for 6 weeks. Unfortunately, the pack was washed away by a storm and was gone when we went to collect it. Instead, we analyzed the natural leaf pack. As Patrick previously discussed, the type and quantity of macroinvertebrates present in a leaf pack can indicate the water quality of an ecosystem. For example, mayflies, which are sensitive to pollution, will only be found in leaf packs with little to no pollution. By manually sorting through the leaves and recording our findings, we were able to estimate the water quality of the two areas. We found many creatures in Lila's natural leaf packs, including dragonflies, beetles, damselflies, and snails. We carefully separated the organisms from the leaf pack in order to observe and record the species. In the Lila leaf pack, we found 5 organisms sensitive to pollution, 39 organisms somewhat sensitive to pollution, and 4 organisms tolerant of pollution. From this, we calculated a pollution tolerance index score of 97, indicating that the water quality is excellent. Unfortunately, our leaf packs at Lake Tawakoni were not as successful. The water level decreased after we placed the packs, leaving the first leaf pack on dry land. Our second leaf pack was ripped and was empty. Since we didn't have a leaf pack to go through, we used the leftover time to go on a guided tour with a park ranger and pick up litter. Why did we get such drastically different results from the 2 packs? Leaf packs form naturally in streams as a result of the running water. However, leaf packs do not form naturally in larger bodies of water, and therefore are not a reliable indicator of water quality in ponds or lakes. To ensure clean water in Dallas's lakes, samples are sent to labs like the one at Central Wastewater Treatment Plant to be tested. We recommend next year's interns place more than 1 or 2 leaf packs at each location. This will reduce the chances of the packs being damaged or moved and will give the interns more data to analyze. They should also put the Lila leaf pack in early again, following the advice of last year. Next, Jose will talk about water consumption.
Thank you, Ainsley. Now that we have covered our research on Lake Tawakoni and Louisville, let's transition to our water consumption research. Like Elba mentioned, EEI teachers go to schools and provide hands-on lessons for students. In the 2011 school year, EEI instructors had taught at 3 elementary schools and 75224. The purpose of the water consumption research was to see if the lessons were effective. Previous interns averaged water use of the saturated school zones before and after the classroom lectures. If water usage levels decreased, then they knew that the lessons were potentially beneficial. In 2013, the interns looked at the 75224 zip code. EEI teachers visited the 75224 zip code and saturated 3 different school zones within the area: Henderson, Jordan, and Russell elementary schools. Using an ANOVA on 12 months of data, the 2013 interns showed water usage went down a statistically significant amount after EEI had visited the 3 schools as shown on the map above. Earlier, Aaron mentioned that impacted schools are schools that EEI has visited. Schools considered saturated are where EEI teachers go to every classroom and give lessons from kindergarten to 5th grade. The houses accounted for in this study on average conserved 49 gallons of water a month, or about 586 gallons a year. EEI may have been a contributing factor to the potential 2.8 million gallons of water saved per year after the 3 schools had been saturated. If EEI can find a difference in one zip code, why not another? The next step is for EEI to conduct an initial study. When looking for a new area, the interns looked for schools EEI had not impacted, and they also wanted an area with higher water usage. The interns have found 75248 with 3 schools not impacted from water conservation education while being in a relatively high water usage zip code. This year's research focuses on the targeted zip code 75248, where Prestonwood, Spring Creek, and Brenfield elementary schools are located. That area, as shown by the map on screen, has a high average household water use rate. On the other hand, 75224, where the 2013 study took place, has a relatively low household water use rate. Now, Aaron will tell you a little bit about why we focus on elementary schools.
So Dallas EEI visits public, private, and charter schools of all grade levels. But why does our research target public elementary schools? By visiting public elementary schools, Dallas EEI is able to interact with a more accurate representation of that zip code's population. Students are placed into elementary schools based off where they live, which results in small school zones in comparison to middle or high school zones. Additionally, middle and high school students tend to have students from other zip codes, but elementary schools are more condensed and local, which provides a better representation of the population within the zip code. The map on the screen is an example of a single high school zone. The green dots are the middle schools, and the red dots are elementary schools. There's a total of 2 middle schools and 9 elementary schools in a single high school zone. This map shows why elementary schools, smaller school zones, provide a more accurate and condensed sample. As Jose mentioned earlier, these are our 3 target elementary schools and their school zones. EEI was able to saturate 2 of these schools, and the 3rd they have not impacted, which allows us to use it as a control for our research. We created this map using ArcGIS. Next, I'll pass it on to Braden to talk about variables.
Thank you, Aaron. During our time at this internship, a very important lesson that we learned is that with every experiment or element you want to research, there will always be variables that impact the results. There are quite a few variables that differ with every zip code that influence water usage. This box lists out the variables we came up with for our research question. The first variable to discuss is precipitation. Rainfall has a big influence on water usage. In theory, the more it rains, the less water you need to use. These maps shown showcase the total average precipitation in 2023, the left being Texas and the right being the city of Dallas. As you can see, we circled the area where our 3 targeted schools are, and actually the variable is the same for those 3 schools. And so this variable becomes constant. But what does that mean? Well, along with learning about variables, we also learned there are some things that affect the result but stay the same across all different points of research, and these are known as constants. Now that that's been explained, let's go back to the next variable, which was temperature. Now, we've all been at the mercy of Texas temperatures, especially now. And with the temperature differences across the state comes changes in water usage. These maps, like the one shown in precipitation, also show the average temperature in 2023 for the left being Texas and the right being Dallas. And just like in precipitation, our circled area shows the 3 targeted schools have the same variable, meaning this one also becomes constant. After temperature, we have the geographic region, which is a very overlooked variable for water usage. But each region boasts its own characteristics and properties, and thus its own unique lifestyle requiring its own usage of water. The left map shows the regions across the state of Texas, and the right map shows the region that Dallas is in. And if you were wondering, Dallas is in the Texas Blacklands Prairie region. And if you may have noticed the pattern when it comes to that circled area, yes, this variable becomes constant as well. In fact, it's constant for all of Dallas, since all of Dallas is in the same region. Okay, so let's take a step back and take a look at the current state of our variables. As you can see from our visual aids, 3 of our variables have actually moved and became constants. Okay, now let's move on to the next few variables. Our next set of variables is for the census data variables. All of the data for these variables are taken from the US Census, and these variables include income, population, and the number of housing units. And these are all for the zip code 75248, which is where our 3 targeted schools are. Now, the data shows that our median household income is $98,584, there's 38,210 people, and there's 18,471 total housing units. And this variable becomes constant because census data covers the entirety of the zip code, and the 3 schools are all in the same zip code. Checking back in on our variables, the census data group now joins the group with the constants. Now these variables are for the city of Dallas. These include the price of water, the irrigation ordinance, and marketing. The price of water is consistent across the city of Dallas. The irrigation ordinance is also a citywide endeavor, and marketing is also the same for the city. So surprise, but this variable becomes constant as well. And thus we have more variables jumping ship to the constants group. Now, as you can see for this study, the majority of our variables actually changed and became constant. We only have one little lonely variable left, and that's education. Education refers to EEI teaching and saturation, and it's not constant because the 3 targeted schools were not all impacted by Dallas EEI. But that just about covers it for everything we have on our one variable and our constants. And I'll now pass the baton on to Raina, who can tell you more about EEI's research study.
Thanks, Braden. As Aaron mentioned, Christina and Nick, as part of the EEI education team, saturated all K to 5th grade classes at Brentfield Elementary and Spring Creek Elementary with water conservation education. As you can see, the dates of saturating Brentfield Elementary were spread out from September 2023 to May 2024, while the dates of saturating Spring Creek Elementary were all in the month of April 2024. As Jose mentioned, EEI is trying to replicate their study from 2013. However, since we do not have a full year's worth of data of educating these 2 schools yet, our research question for this year is to see whether or not 1 month of water conservation education can create an impact on household water usage, specifically for Spring Creek Elementary. For this reason, this is not a full replication of the 2013 study yet. Rather, this is just an initial analysis. Prestonwood Elementary was not saturated with water conservation education, so it will serve as the control group for this experiment. So, we collected data of household water usage zoned to both Spring Creek Elementary and Prestonwood Elementary from the month of May 2024, which is 1 month after saturating Spring Creek Elementary with water conservation education. We compared this May 2024 data to the data from May 2023, a month earlier. Next, Carlos will go into further detail about the schools and where we retrieved the household water usage data from.
As Raina mentioned, the 2 schools that we're focusing on this summer are Spring Creek and Prestonwood. These 2 maps were created using GIS, and the map on the left includes the Brentfield school zone as mentioned by Aaron earlier. The map on the right, though, is the map that we will be focusing on today, excluding the Brentfield school zone due to it being used in next year's full analysis as opposed to our initial analysis that we're conducting this year. Another thing Raina mentioned was the household water data. What is that? The household water data is data given by the city of Dallas that talks about how much water is being used per building, per household, in whatever zip code. So, we got the zip code data for where all 3 of our targeted school zones were, and then we cleaned the data by filtering out all the addresses until they were only directly inside of our school zones. We then filtered the data more to make sure it was only buildings that were individually metered. This left us with addresses that were inside of our school zones that were individually metered homes, apartments, or duplexes. And then using GIS, you can see on the left, we have the map with all of our data, and on the right, we have the filtered data with only addresses inside of our school zones.
Now that Carlos has shown us where the data of household water usage comes from, here's what we know about the education at Spring Creek Elementary. What we know includes the date of educating all K to 5th grade classes, the number of kids that were educated, and the number of kids that committed to the water promise. As Elva mentioned previously, the water promise asks students to promise to turn off the faucet when they brush their teeth. And as you can see, the students have a 100% commitment rate to the water promise. The results of EEI's research show that there was actually an increase in water usage in both school zones when comparing the data from May 2024 to May 2023. When we ran the analysis, we found no statistical significance between the data from Prestonwood and Spring Creek, the control group and the variable group. However, Spring Creek did use less water in May 2024 as compared to the control, Prestonwood, and this informs us that we need to look at a full year's worth of data. Also, our data was from an average of 1,103 households in the Spring Creek zone and 1,512 households from the Prestonwood zone. However, not every household in these zones contain a student that attends Spring Creek or Prestonwood, as there are around 400 students that attend Spring Creek and 470 students that attend Prestonwood. This means that not having specific students' household addresses is a limitation in this study. For a more detailed dive into the statistical analysis of how we determined the results, we ran a difference in differences model, which is a form of linear regression to test if there's a statistically significant change in the response variable, water consumption, as a result of treatment, EI education, between two groups, EI impacted school and control school attendance zones. This model determines if change occurs within two groups because of the education treatment, and if the amount of change is statistically significantly different between the control group and the variable group. However, you will note that we already see an issue due to the outliers. These outliers, when averaged with the whole, can skew the results. Often, we would remove the outliers and run the analysis again. Looking at the statistics on the right of the slide, the interaction term school zone times year is included to capture the differential effect of the treatment over time. So, if school zone times year is statistically significant, then there's a statistically significant difference in the change in water consumption between the two school zones. It is important to note that although we mentioned in the last slide that there was less water used by Spring Creek compared to Prestonwood, this difference was not statistically significant.
In science, no matter how established a certain study may be, there will always be limitations present. Here are a few that we found in EEI's research regarding water conservation. Of course, the most prominent limitation is that we would need more aligned data to determine if elementary education did actually have an impact on water consumption. Although there are almost 1,100 households in the school zone, not every house has students that actually attend Spring Creek, the school that received water conservation education. Along with this, not every student who attends Spring Creek was actually taught. For example, only students in grades kindergarten through 5th grade were taught, even though the school goes up until 6th grade. Given these factors, it is nearly impossible to find a statistically significant difference because there were not enough kids taught in order to impact the water usage of the entire school zone in only a month. Along with this, the outliers that we found in our data were not removed. Lastly, we also did have to draw out the school zones by hand because we did not have access to the layers. Next, Carlos will talk to you about some changes for the future that we believe should be implemented.
Thank you, Alyssa. What we realized when analyzing the data is that the 1 month time period that we were curious about was not actually enough to notice any statistically significant changes in water usage. So next year's interns will be going through an entire year's worth of data to hopefully offset this. In addition, we will also be including a couple extra covariables such as precipitation and temperature into our linear regression models. With the addition of covariables, we will better be able to understand the underlying causes for changes in water usage, whereas previously we could only understand the statistical significance between EEI's teaching and water usage. We can now do that for the other two covariables as well. And lastly, we would always address certain limitations of the study, such as the manual school zone boundaries, by directly reaching out to the schools and getting their layers, as opposed to making our own manually, and by more thoroughly going through the data to clean up the outliers. So, we would like to summarize the research that we have done and provide some insights for next year's interns to consider. For our research, the biggest change will be the research question, which becomes, does saturating the Brentfield and Spring Creek school zones decrease water usage when compared to Prestonwood, our control? This is different for two reasons. The first being the addition of the Brentfield school zone that we did not consider in this initial analysis. And the second is the year's worth of data that will make this a full replication study as opposed to just an initial analysis. Then, as stated earlier, we will analyze the data more thoroughly, use covariables, and get the official school zone boundaries. For our leaf pack research, as Ainsley discussed earlier, our biggest concern is leaf pack redundancy. This just means that we will continue to place leaf packs in early, but we need to include more leaf packs in all of our locations and choose their locations more carefully to do whatever we can to shield them from the elements. We wish the next year's interns the best of luck in the continuation of this research while we move on to some final thoughts.
Thank you, Carlos. Now, before wrapping up the presentation, we all wanted to share our biggest takeaways that we got from this internship. I'll hand it to Braden to start us off.
My biggest takeaway is that I believe the knowledge of how our wastewater is treated should be common knowledge to everyone. It's a very insightful information and it clears up many misconceptions we have on water cleaning practices and distribution.
I learned to appreciate the importance of teaching future generations about the environment, as they will someday be responsible for managing and maintaining our ecosystems.
One of my biggest takeaways from this internship was that there are a variety of jobs available in Dallas water utilities.
My biggest takeaway from this internship was that after visiting the various water treatment plants, I learned that the water cleaning process involves many steps and is held to high standards that must be strictly maintained. This means that the water sent out to our houses is basically 100% clean and can be drank, contrary to what I previously thought.
So one of the most surprising things I learned in this internship was that there's only one real lake in Texas and the rest are man-made reservoirs.
So Serenity's biggest takeaway that she got was the fact that water is recycled. She had never really thought about how many times wastewater is actually transformed and cleaned into the water that she drinks.
Hello again, my name is Patrick, and after this internship, I learned a more nuanced way that I wanted to pursue my career, and I also gained a greater passion in water conservation and environmental efforts. Lastly, I gained a more realistic point of view of what it means to construct a water conservation culture and how I'd like to apply that in my life.
My biggest takeaway is learning how the cleaning process of the water is, and how us throwing trash away can make that process harder.
I learned more about the research process, from the creation of the idea to the amount of effort that goes into making sure all of your claims are legitimate.
Like Serenity, my biggest takeaway is that I never realized how many lives water goes through before we can drink it. The number and power of filters, machines, and systems that are used to treat and clean the water is truly mind-blowing.
So, in conclusion, not only did we learn a lot while interning for Dallas EEI, but we also had a lot of fun. We got to learn about water conservation and quality and the different careers that are involved in this process. I can definitely say that this was a worthwhile experience for me. As a quick recap, some of the things that we did over the 5 weeks included making presentations over research articles, meeting with professors, taking various field trips, leaf pack research, and making maps with GIS. The things that I learned with EEI are definitely going to stick with me and help me become not only a better student, but a better person. And I also want to give a special shout out to our mentors who were present and supported us through this journey. I want to say an extra special thank you to Ms. Capybara Christina, Ms. Koala Crystal, Mr. Narwhal Nick, Mr. Bear Ben, and Mr. Cheetah Charles for everything that they did. They taught us so much and served not only as mentors, but as a friend to all of us. And lastly, we of course want to thank all of you for giving us your full attention and support today. Please don't hesitate to ask us any questions or share any comments or concerns that you have. Thank you.
Hey y'all, I'm Dr. Ruby Thompson, and we started the Dallas Environmental Education Initiative in 2016. So for some folks, that's a really long time. For me, it's forever. I want you to know that these fantastic kids did an amazing job, and if you would please stand and give them that credit.
Yes.
I also want to personally thank you guys for showing up today. You guys can sit. For showing up today. It's really important that they can share their work, and I think that they did a phenomenal job. I appreciate the city folks that have come, and they are appreciative of all the work that you do. Thank you for your willingness to do the field trips and to do the teaching when they came out to your areas. Thank you to the parents for loaning us your kids for 6 weeks to do research. And I just want to also thank my project coordinator, Christina Reeder, Christina Latimer. Christina started with me when she was 18. She wasn't a Latimer then. Nick.
He's right there.
Okay. Nick is our newest project coordinator. We also have Crystal Tony.
Right.
Crystal. Graduate student in my lab, and she is working on environmental education research and trying to get more people to understand the environmental places that are around you in urban environments. And so she's doing a fantastic job working with the EEI, but she's also working on her dissertation. Yeah, that's just a quick reminder. And then Ben, we borrowed for 6 weeks. And Ben taught the statistical analysis and the GIS. And then, of course, Charles, who takes care of us all. So I'm going to give it back to Christina, but I just wanted to take a moment to really personally thank you and to thank the city of Dallas for allowing us to have these experiences for our young researchers.
Thank you, Dr. Thompson. The students are more than happy to answer questions. We do have a couple of mics, so we can come bring those to you guys. And then if you have a specific question for a specific student or slide, we can pull that up for you all. So, any questions? All right, Crystal, start us off. What's your question? Oh, we got a question.
Yeah, I've got a question. What you folks think you would like to use? I think I'm good with that. And one of the students